Earthquakes are one of the planet's most lethal natural forces. In this film, we're going to examine the anatomy of an earthquake. What happens to turn a seismic hazard into a seismic disaster? To do that, we're going to use this virtual cube of the Earth's crust to explore what happens when an earthquake at depth meets a vulnerable population above. Here's the unsuspecting target, a typical hilltop town, with a historic old part here and modern suburbs here and here. Home to a few tens of thousands of people, with a constant stream of tourists adding to the numbers. Life's pretty normal, really. There's been a few minor tremors in the preceding months, but nothing out of the ordinary. Few, if any, of the inhabitants or the visitors have noticed this, though. A steep slope cutting right through the heart of the town. That is an earthquake fault line. If we zoom out, we see that the fault descends deep beneath the town, down to about 10 kilometres. And down here, the stress is at breaking point. The fault itself is locked. The blocks of rock on each side are snagged on rough patches that prevent the sides from sliding past each other. But the thing is, those minor earth tremors are picking away at those strong points, breaking them down. And eventually, the points of resistance give way. And with nothing holding it back, that section of the fault slips. The sudden rupture of the fault releases seismic energy. In this case, the equivalent of a thermonuclear blast, a magnitude 6.5 earthquake. Seismic waves radiate out from the point of rupture, heading outwards. Now, to really understand what's going on, we need to slow those waves down and zoom in. The seismic ruptures unleash different kinds of vibrations. One set are pressure waves, P waves, that push and pull the rock and rapidly send pulses of vibration ahead. Another set vibrate the rock from side to side, perpendicular to the motion of travel. Most rocks are weaker in this sharing motion, so the S waves travel slower. If we speed things up again, we see that those fast P waves travel at 10 kilometres in just a matter of seconds, but the sharp judders they produce go largely unnoticed. That all changes a few seconds later when the first shear waves arise, because their vertical and sideways lurches make people realise that they're experiencing an earthquake. Almost immediately, the full force of the earthquake is unleashed, and that's because a third set of seismic waves has joined the action. Surface waves, slower but larger, rolling and twisting motions. One after another, the surface waves crash into the town. They range from side to side and up and down. Something like 95% of the seismic energy gets released in the first 10 seconds or so, but the shaking continues for 30 seconds, 40 seconds, a minute. People get thrown off their feet, and it's those motions that buildings are most vulnerable to. Their fabrics strain as they try to bend and flex to the convulsing ground. Generally, it's not earthquakes that kill people, it's buildings. To the town's inhabitants, it would have seemed much longer, but it's taken barely 60 seconds for the tremors to finally cease. But in that short period of time, much of the historic centre has been levelled, the ancient masonry offering up little or no resistance. Nowadays, at relatively low cost, buildings can be designed to be so-called life-safe, maintaining their integrity without collapsing, kind of like a car bonnet designed to crumple on impact. But these reinforced concrete buildings were put up decades ago, before the stringent building codes. They just weren't strong enough or flexible enough to withstand the intense shaking. The layout of our cities too has a big effect on the number of casualties. Many large new hospitals get built on the edge of the town where the land's cheaper. But if key lifelines like roads and bridges fail, then the route to the hospital can be severed, cutting it off from many of the injured. The most tragic loss of life, though, has occurred here, close to the river. In this area, the softer sediments just makes the shaking far more intense, and it lasts longer. The results are lethal. A modern school, which should have been built to tough earthquake standards, has crumpled. As the dust clears, it's obvious that many of the fatalities lie among the ruined masonry of the historic centre. But it's the poorly constructed modern buildings that claim most of the lives. Buildings that could have stayed up, should have stayed up, but didn't. In countries around the world, public buildings like schools and hospitals and municipal housing schemes tend to be built fast and cheap. Compromises are made on location and materials. Corruption of local officials allow the approval of designs that don't even meet the most basic seismic building codes. In the end, what makes populations fatally vulnerable to earthquakes is poverty and poor governance. It's a scenario played out to different degrees in countless cities across the earthquake-prone parts of our planet. Here's an image showing the earthquakes that have happened across the globe. And here are our biggest cities. Today, more than half the world's population live in towns and cities. And some of the biggest lie in earthquake zones. Over the next century, earthquakes will shake urban sprawls housing upwards of 12 million people. A direct seismic strike on such a megacity has the potential to cause 1 million deaths. It's a truly terrifying prospect, and one that we've not seen the like of in human history. So the decisions that we make now about how to build and manage our cities will go a long way to determining the fate of those who live in earthquake country.